right, what's up, guys? So today we are going to talk about 2.05, 2.06, and 2.07. Introduction to matrices, adding and subtracting matrices, and then multiplying and dividing, I think, matrices. To start off, matrices look like this. It's just, you can think of it like a list, a two-dimensional list of numbers or of anything. They don't necessarily have to look like 2 by 2 like this. This is 2 rows and 2 columns, so it's considered a 2 by 2 matrix. We can have, this is called a column matrix. It's just a column. I feel like these are pretty self-explanatory definitions. This is a row matrix. It's just a list. And there are a lot of things you can do with matrices that you can't do with just regular numbers, or that you can do with regular numbers, but it's helpful to look at it as a matrix. For example, a lot of times with computers, images are represented as matrices, and then you work with the matrice instead of working with the individual numbers to make the image change, like applying filters and things like that uses matrices. So a lot of times a matrix is represented by, like, saying A2, 2. This would be matrix A, and this is row column. So we have 2 rows and 2 columns, and we say, okay, we're looking for the second row, second column. So we are looking for this element. That is what this specifies. When we read out a matrix, we're reading row by row. So we would read this as 2, 2, 1, 7. That's just useful for when you say it out loud. A lot of times you find like what this is called is, like, if it's A equals this, then the order of the matrix is written like this: A, 3 rows, 2 columns. So this is called the order, and it's just, it kind of gives you an idea of what how many elements are in there and what it looks like. Or sometimes this is written just as a 3 by 2 matrix. So something like that. So if you're looking for order, it may be written like this, it may be written like this. Either one is correct, and they both represent the same information. Sometimes it will give you something like this, and it'll say, okay, identify this element. So you need to start looking for the element. So you're looking for row, column. So we're in the first row, second column. So we're looking for element 2. So that would be 2. What you got? Go like this and not like... You go left and right first, and then up and down. Row and then column.
That's how you would read it if you're on the phone?
Well, if you're reading it out loud, you're reading rows and then columns. So like you would just read, like for this A right here, you're just reading 1, 2, 2, 4, 3, 7. Does that make sense? But when you're looking for an element like this, then you're reading row. So first row, which is this number, second column. Make sense? Okay. So like I said in the beginning, this is considered a row matrix. Sometimes they don't have commas. I just put commas in there out of habit. They might look like that. It's just one row. Sometimes you'll have a column matrix that's just one column. 1, 2, 3, same thing. A square matrix is just that. It's square. So it's 2 by 2, 3 by 3, 4 by 4, whatever. A zero matrix only has zeros in it. And a zero matrix can look like anything. So you can have a matrix with just one element in it. And this is a zero matrix. This is both a row matrix and a column matrix and a zero matrix and a square matrix. But occasionally you'll have not a zero matrix because of the one. Sometimes they're called null matrices if they have all zeros. Sometimes it's zero, sometimes it's null. So I think the last problem on, well, actually, never mind. It's not the last. So mostly what your assignment wants you to do is identify, like, just the stuff that we've gone over, identify specific elements. You're doing that by row column. Order is usually written as 3 by 2, 2 by 1, whatever. To look for column, square, all that kind of stuff, you're looking for this. So this would be a square matrix and a zero matrix. This is row, column, square, and a zero. This is just a row matrix, and this is just a column matrix. They don't necessarily have to just stick to one. They can be multiple.
Can you write it on top?
Write what on top? Sure. So this is a this is all of the above. This is a zero and a square, and this is a column. They all kind of fit in what you think they would look like. If we called it a column matrix, you would think, okay, it's probably got a column. If it's a row matrix, it probably has a row. If it's a zero matrix, it's filled with zeros. Sometimes you need to multiply matrices by things, and you can multiply matrices by other matrices, but what we go with in this section is just multiplying by some number. So if we have 4, -3, 0, this is this is number 12. Wait, yes, this is number 12, but that is not the right matrix for number 12.
What does it mean by 4D?
It wants you to multiply 4 by matrix D. Matrix D is 0, 0, 0. It will be 0, 0, 0 because you're multiplying each element in this by 4. So when you multiply 0 by 4, you get 0. 0 by 4, 0, so on and so forth. So this is kind of a property of zero matrices. If you multiply any normal number by them, you're just going to get 0. So let's look at 13. -2a, and I'm just writing matrix A out here. 4, -3, 0. Okay, so when we multiply, we're just multiplying each element by it, and we're putting it in the same place. So the matrix isn't going to change shape when you multiply. So when we multiply, we'll get -8, 6, and then 0. So this is your answer. So we will work 14 and 15, and then we'll move on. 14 is 7e. Okay, so when we multiply in here, we're going to get a matrix of the same shape, which is not always the case. So this is specifically, we're getting a matrix of the same shape. So 21, negative 42, 63, negative 49, 0, and 35. So pretty simple concepts, just understanding how to read these and, you know, a few special types. And then number 15, 2 times C. It's not hard math though. Okay, so we multiply all these numbers by 2. 46 by 2 is going to give us 92. 92?
92. It's 92.
Thanks, Jada.
18 times 2 will give you 26.
36. Negative 36. 4.
Okay, that's 4. I know that.
86. 16. That. Forgive that abomination. This is negative as well. Don't forget to keep your signs. So that is
A matrix.
that is a matrix, and that is how you handle multiplying them by a scalar.
This is just called a box.
They're not always boxes, but you can have 3- and 4-dimensional matrices. They can get really big and really complicated.
Okay, so 5, when it said order, I'm not telling it columns and rows, so it would be.
For number 5, you're telling it
4.
row by column.
So is it D 4 4?
4 by 4, 4x4.
What? It's not like number 8. I mean number 4.
Okay, so what it's doing in number 1 through 4 is it's asking you to identify an element. It's asking you to find one specific element, and you're doing that looking for 1, 3 on number 1.
1, 3. Wouldn't that be 4?
So you're looking for row, and then you're looking for column. So it is 4, yes.
No, I'm talking about 5.
I know. So then on number 5, it's asking you to count the rows and count the columns, and write row,
D 4 4.
column.
4.
This.
4 times 4?
It means 4 by 4, but
Yeah, I get that.
yes.
You write the box too?
No, I just kind of box it just to make it clear.
Oh, C is the answer for 6. Okay, C is with C. 5 is with D, and D is with 7.
Okay.
Huh?
What are you talking about?
So do y'all feel okay with the introduction to matrices? I feel like this is pretty easy. All right, let's go to addition and subtraction of matrices. Addition and subtraction of matrices is, I think, another pretty simple concept once it's actually been taught. You need matrices of the same shape. So you can't add or subtract something that's 1 by 2 by something that's 2 by 1. So if we have 1, 2, 3 plus 2, 3, 4. This isn't cool. We cannot do this. There is no answer. Same type of box. So if instead we had another column matrix with 2, 3, 4, this is okay. When we add these, all we're doing is adding corresponding elements. So we're adding this element to this element, this element to this element. So we get 3, we get 5, and we get 7. And that is our answer. So with matrices like this, you are going to get something out that is the same shape. When we get to multiplication, you're going to understand why I keep harping on that, because you're not going to get the same shape every time when you multiply. But with addition and subtraction, it works just like normal addition and subtraction. So if we do a little bigger problem, maybe 2, -4, I don't know, let me move this over and make this a little bigger.
How can it not be possible?
It's just not. I don't know. I mean, can you add 4 plus an apple? Is that possible?
But it says it's not possible where it does not exist. How it don't exist if it's on the paper?
Well, apples exist and the number 4 exists, but you still can't add them. So if we add this to, I don't know.
One that doesn't exist.
Okay. That one doesn't exist.
No, because it's not the same type of box.
Oh, it's like terms.
Yeah, they have to be the same shape.
Oh, okay, I got that. I
How
got
did you
that.
not get this?
Helium.
Okay, so 3, 2, 1, 4, 5, 6. Okay, so this exists because they're the same shape. So we add this one and this one. 3,
4.
this one and this one.
1. -1.
-1, so on and so forth. We get 7. We get 3, 9, 8. Answer. Okay, so this is the addition problem. What if they were subtracted? Ooh, it's the same thing, you just subtract them. It's really not. All right, we'll get there, promise. All right, let's do a subtraction problem right here. So 2 minus 1, 1, -4 minus 3 is going to give me -7. -4 minus 3. See what I'm saying? -7. -1. What else?
Then -2
No,
again.
-2.
Then it
They're almost
does.
-1. -4.
And
-1 is 0 minus 1. Because it's negative.
what is 0 minus 1?
Oh, never mind.
Interesting. 2 minus 6, -4. So if we subtract, we get this. If we add, we get this. Pretty simple stuff.
Screenshot. No, it's a screenshot because I might forget.
Okay, so things that you can do is with, hang on.
What can we do?
You can, these are going to be kind of self-explanatory, because you can do it with normal numbers, but it's not always the case. You can do a plus those are the same thing when you're talking about matrices. That seems pretty obvious. This is called associativity, and it works with normal numbers as well, but it doesn't always work with everything. We can also switch the place, so B plus A, or switch the order. This is called commutativity. And then we can also do
I feel like he's doing 207.
This eyebrow is about to freak out. Ooh.
no. So you can also multiply, like if you multiply a scalar by or if it's multiplied by some addition problem, you can do it like this as well. This is called the distributive property. What's up?
Are they gonna incorporate vectors into this at some point in this lesson?
Vectors are matrices. They're just a specialized form of it.
Kind of doing that in
No, I don't think so.
it?
But you're gonna see things that are similar. So if you're familiar with vectors, you're probably gonna be familiar with some of the stuff that we do in the next section. So if we talk about an identity element is like, if we're talking about addition, an identity element is something that you can add or you can add to something and get the same thing. So if you want 1 plus some number equals 1, then this is always 0 for addition. If we're talking about multiplication, 1 times some number equals 1, it's always going to be 1. So an identity element is something you can do this operation by and then get the same element out. So for matrices, the identity element isn't always just one thing. So if we have 1, 2, 3, and we want to get this out, if we're adding, then we need to add a matrix of the same size filled with zeros.
So it's basically just like regular addition and multiplication and everything, just in a box.
Yes.
You know, that
It's
so much harder than that. So.
it's not regular multiplication. Multiplication is different. Everything else.
Where would this be used?
This is used mostly with like computers, with images. It's very, very well, like that's how I use it. I use it regularly with images. If you do any kind of like filters on Snapchat, filters on Instagram, whatever, this is all matrices. Like you can look up how, like if you have fun time and want to be a nerd later, you can Google how images are represented in computers and just like the basics of it. And it's actually pretty interesting, I think, but y'all may think I'm a nerd, so that's okay. So anyway, the same thing, if we want to do this with multiplication, it's not zeros and it's also not just ones either. So these are not the same thing. So just be aware of that. With addition and subtraction, our identity element is a 0 matrix of the same shape. Of the same shape matters. Okay, let's do the worksheet. Let me pull the worksheet up.
Oh, wait, we're on 12:6. I was looking at 12:7 because you were technically going over 12:7.
How come?
By going over it.
Well,
Hey, did anyone touch your Patrick?
what do you want, Jordan?
Maybe a word problem.
Do what?
A word problem.
No, I need to understand how to do it first.
Which word problem would you like me to do? I'll do it.
The hardest one.
They're all easy to do.
The most complicated.
Okay, let's start with number 2. And then we will move on down to a word problem.
You on 12:6?
Yes.
Stop raising my hand.
Hey, y'all, today is February 2nd,
22, cool.
It's 2/2.
Okay.
That's how the TikTok was said. I figure out, it was February 2nd.
4b plus d.
Because they told, let's spend with all the birthdays on it. And you got February 2nd.
Oh,
I mean, you're early.
I'm not out, Patrick.
You're not either, man.
Plus.
What are these column boxes on here for? Are we supposed to use it?
What do you mean? Where? Your answer is going to go in there.
You want answers supposed to go inside of it?
Yeah.
Oh, that's the extra box?
I was gonna write my
Oh,
little
wow.
thing in
I just told you that.
Then what's the little,
We have to write it on the side.
Okay, so if we do 4B plus D, first thing we need to do is multiply, just like normal, we do PEMDAS, because we're multiplying by this 4. So we get 0, 0, negative 4, 0. And then we add 0, negative 1, 16, 12. And I'm just not drawing I'm not drawing the borders just to make it a little quicker. So we add across, we get 0, negative 1, 12, 12. Answer.
So what's the little box under it for?
I do not know.
What is what?
I guess it says if it's not possible, you write does not exist. So I would guess that would be for the does not exist part.
Okay, 4 is
There's
not
none of that
possible.
doesn't exist.
4,
Why is 4 not possible?
because it's a little one.
But everything you're adding together is just a column.
No.
4 can exist
Well, I don't know which ones doesn't.
only if they're different shapes. So if you write them down and they just don't look the same, it doesn't work. Okay.
did you hear that?
Everybody knows what you done.
Okay, so let's look at number 6. We do use the following table to answer the questions that follow. The table represents the number of magazines on the shelves of 2 different stores. So on Wednesday, the following sales were made: 12 Sports Illustrated, 6 Reader's Digest, 5 Better Homes. Store B, 2 Sports Illustrated, 3 Reader's Digest, 6 Better Homes. Write a matrix that represents the number of magazines sold on Wednesday. So I feel like we're just taking those and putting them into a matrix. So I'm going to put them exactly like they're written. We're going to do store A, 12, 6, and 5. Then we do 2, 3, and 6. There could be made a case that you flip this and do it 12, 2, 6, 3, 5, 6, but I'm gonna go with this just because I think it makes more sense.
So we don't do the, I think the one separate store A and store B.
No, I mean, if you're making the matrix that represents the number of magazines sold, they need to all be the same. They need to.
Two by. I was wondering if you do 12 to 6 or 5 like this and then add them plus the.
I don't think so.
Yeah,
Maybe you could.
I think it's 12, 2, 6, 3, 5, 6.
So you want it to be a column matrix instead of a row matrix.
Yeah, because that's how they like the computer column.
Okay, that's fine. I mean, I'm not your teacher. I didn't make this, but I mean, if you want to write it as 12, 2, 6, 3, 5, 6, and do that, the chart matters on number 7. Because you want to write the matrix that represents the number of magazines remaining on the rack. So pretty much you need to take,
I'll put left in there just to be safe.
that's fine. I think we're going to end up using this one on number 7. So let's just stick with that one. Let me move this up here. So now let's put this here and make another matrix for what is left or what is on the shelves to begin with. So we do that with 14. I'm just going through the table. 8, 14, and 11. And we're doing a subtraction problem because we want the number of magazines remaining on the rack. So if store A has 14 and store A sells 12, then this is what it's going to give it. This is number 7, yeah. We did number 6. This was the answer to number 6. This matrix that I'm drawing the arrow to right now. What we're doing right now is number 7. We're using the matrix that we made, and we're finding a matrix with the number of magazines left on the shelves or on the rack. So this is from the table. All I did was just copy the values down into a matrix. And now we're going to subtract what they had minus what they sold, and we're going to get what's left. So we're left with 2, 6.
2 and 5.
2 and, okay, so we do 12 minus 6, we get 6. 14 minus 3, we get 11. So exactly right. This would be the answer to number 7. And you can probably move these closer together. I just kind of spread them out a little bit. Number 5. Number 5 is the exact same thing we did on number 2. It's just, you just multiply something by every one of them. If you want to do it, we can, but I mean, it's the exact same thing. Okay. So we need 2.
So proud of us. Right, I'm still gonna be behind. Well, we still gotta do 207. Yeah.
That's what I'm worried about.
No, we don't gotta do it.
Okay.
Well, we can do this probably. That's something we can do on our own.
2D. 2 times 0, negative 1, 16, 12, minus 3 times B. Jade, if you haven't noticed, I write big by now. 3. Just for you. D.
Looks like lips. The 3,
Crap.
the big 3 looks like it's kissing the
I
lips.
see the big 3.
Okay then.
I cannot see the big 3.
It is hard to.
I'm big on my paper too.
Good. That's the way to
I
go.
didn't even realize it till now.
All right, there we go. So first thing we're going to do is multiply. So we multiply by each of them. So I'm going to multiply my 2 in, I'm going to multiply my 3 in, and I'm going to multiply my 3 in.
This little space is big problem.
2 times negative 1 is negative 2. 2 times 16 is 38.
32.
32.
Thanks, Jada. You got there.
2 times 12 is 24.
So what I'm going to do is just multiply this 3. There could be a case made for taking the negative sign with it and just turning it positive. But leave the negative sign and just take the 3 in. That will make it a little different later.
So just multiply it by 3.
I think I'll do that.
Yes.
It doesn't matter because it has zeros in here. And 0 can be negative.
Bro, what are you talking about?
Exactly.
What are you talking about?
48. Oh, no.
She was trying to know what she's talking
Okay, so now we have to do these in order because we have our signs that are different. So this has to subtract by this. So when we do that, we end up with 0, negative 2, 32 plus 3 is 35, 24 minus 0 is 24. Plus this guy.
Wait, how's it 35 and?
Like, space for this, bro.
So we have
It wrote smaller now.
32 minus 3. Negative 3, sorry. 32 minus negative 3.
Two negatives beside each other, you turn into a positive.
Two negatives make a positive.
But 32. No, 32 minus.
So we have,
Oh, okay, never mind. Now I see.
you got it? Okay.
You figure out your own, bro.
So now we do this problem. 0, negative 5, 35 plus 48, whatever that is.
I thought when you think the adding comes from. Or whichever one's closest to the left.
83, it's whichever one's closest to the left. And then 24 plus 36 will give us 60. Answer.
Hey, my mom just texted me, said she wants something like this.
All right, y'all ready to move on to the next section?
Yeah.
Do what? I'm sorry.
It's not disturb for her. They told me, I don't answer the phone for them. I don't answer the text. I'm getting a flip phone. And that sounds like
Good.
my mom.
All right. So let's go to 2.07.
Organizing.
That's me.
Actually, I always get my phone too.
Oh,
Imagine.
One day she'll come to
I know you're
school.
not talking.
She'll be like,
I'm
I'm she'll come in and read
Oh, I
it.
did, right.
Okay, so matrix multiplication is more difficult. It's not more difficult, you're just going to have to keep track of it a little more. This is where the shapes don't have to be the same. They actually still have to be specific, but they just don't have to be the same.
This is why I hate math. Just throw every rule out the book and just say, oh yeah, by the way, you don't have to.
They should have left it with y equal mx plus b. I didn't like
You
that.
just-
All right, so if we have this, we can add it. But in fact, we can multiply it. When you multiply, you do row by column or column by row. So you multiply this by this by this, and this by this. So it still stays the same. You're just, one of them is flipped and one of them is not. So if we do this, we are going to get, yes, I'm trying to see what order it wants it in.
You got some, he probably tell the person to get a bologna sandwich from Jack. They have that? They
Now.
got in his bag.
So they do have to be the same type of font or type of matrices, they just don't have to be
What do you mean by type?
like a box matrices or like
Matrices in general are all boxes.
well, I mean, not like, I'm trying to think on it. Like, it doesn't have, like, it still would have to be a row matrices, but it could be flipped to column matrices.
You have to have a row and a column for multiplication to work. You can't have a row and a row. That won't work. You have to have a row and a column or a column and a row. Does that make sense? They have to so if you're trying to multiply something with the shape 1, 2 by something with the shape 1, 2, this is not going to work. So like this would be something with 1 row and 2 columns. Make sense? But if you flip it to 1, this will work. They have to be backwards like that.